Hello, so today we are going to learn all about ratios. Well, first off, what is a ratio? A ratio is really a comparison of two different values, and sometimes those values are related in the same set, meaning it would be a part-to-part ratio, and then sometimes you're comparing a part of a group to the whole, and that would be a part-to-whole relationship. Okay, so to give you an example of the two different kinds of ratios and the three different ways we can write them, I have a set of data here, and it's kind of given to us in a sentence. And it says, there are 2 girls and 8 boys on a local basketball team. So we are going to use this information to find the ratio of boys to girls and then also girls to total teammates. One of the things that's super important when you're writing a ratio is to make sure the order stays constant. We need boys to girls. So when we have a ratio of boys to girls, our number that represents boys must always come first. Here, there are 2 girls and 8 boys on a basketball team. So boys is represented by the number 8, and girls is represented by the number 2. So that is a ratio of 8 to 2. Now, one thing that's important to know with ratios is there are 3 different ways to write ratios out. You can write ratios out by writing 8 to 2 out verbally, exactly how we just did. You can also write it as 8 to 2 this way, separated by a colon. And then you can also write it as a fraction, 8 to 2. As you can see in each one of these, my 8, which represented boys, was always first because I needed to maintain my ratio of boys to girls. Now, one thing that you can also do is simplify your ratios. This ratio right now perfectly represents the number of boys to girls. However, if I wanted my ratio in simplest form, I could simplify this value. And we simplify our ratios by finding a number that can go into both of those values. What number goes into both 8 and 2? 2. So I'm going to divide both of these numbers by 2. 8 divided by 2 is 4. 2 divided by 2 is 1. So now we have a ratio of 4 to 1, which is equivalent. 8 divided by 2 is still 4. 2 divided by 2 is 1. And 8 over 2, if we divide each of those by 2, we have the fraction 4 over 1. So this is our original ratio that we can write, but if we wanted to write a fully simplified ratio, this answer would work as well. Okay, so now on to girls to total teammates. So as you can see, the order is girls to total. So we need to list the number of girls first. They told us there were 2 girls on the team. And we need to compare that to our total teammates. Unfortunately, they didn't tell us how many people there were in total, but they did tell us there were 2 girls and 8 boys. And in order to be on the team, we can combine those 2 subsets to find our total. If there are 2 girls and 8 boys, that means there's a total of 10 people on the team. So the ratio of 2 to 10 would represent the number of girls to total teammates. Now, just like the last one, there are 3 ways to write a ratio. You can write it out verbally, you can write it out separated by a colon, and you can also write it out as a fraction, okay? Now, I always look to see if I can simplify my ratios. This is a totally valid answer, but it's always nice to simplify as well. And looking at this, I can divide both 2 and 10 by the number 2. 2 divided by 2 is 1. 10 divided by 2 is 5. You need to make sure you divide by the same value so it stays proportional. 2 divided by 2 is 1 to 5 again, and then we have 1 to 5 again. So this is a ratio that represents the number of girls to total teammates. This is also a ratio that represents the number of girls to total teammates. This bottom set is fully simplified. The top one is still completely valid. It's just not fully simplified. Okay, so now we're going to get into equivalent ratios. And equivalent ratios are 2 ratios that express the same relationship between their values. It's just they're going to look different because there's a scale factor that separates them. The easiest way to identify whether or not ratios are equivalent with one another is to simplify them. So 20 to 44, 14 over 26, 22 over 10, and 70 to 130. Now, as you can see, some of these are in different forms. We have the colons, we have the fractions, and then we have our verbal ratios. So one of the things that I think is easiest is to get them all looking the same first. So I'm going to keep the order the same, but I'm just going to put them all in fraction form. Because ultimately, I'm going to simplify my ratios to find out which ones are equivalent. And when I simplify things, I always find it easiest to do that in fraction form. So, starting with my first ratio here, I have 20 over 44, and I can try to think of numbers that I can divide both 20 and 44 by. So when I see the numbers 20 and 44, I see that they're both even, so I know they can be divided by 2. Now for me, I always try to think of larger numbers that I can divide these values by. There's nothing wrong with dividing both the top and bottom by 2, but I also know that the number 4 goes into both 20 and 44. So I'm going to divide by 4 to try to save myself a step. 20 divided by 4 is 5. 44 divided by 4 is 11. Now looking at 5/11ths, there is not a number that both 5 and 11 can be divided by, so this one is fully simplified. It may or may not be equivalent to one of these later, we just have to see. Next one, 14 to 26. Well, I look at 14 and 26, I know 14 is 2 times 7. 2 can go into 26, but it cannot go into 7. 2 can go into 26, but 7 cannot. So therefore, I'm just going to divide by 2, so that's because that seems like the only factor. 14 divided by 2 is 7. 26 divided by 2 is 13. Looking at 7 and 13, there is not another number I can divide both those by, so that one is done. Now looking at these two, they are not equivalent to each other because they're in simplest form and they're not the same. Moving on to the next one. 22 over 10. I know immediately this is not going to be equivalent to either of these because the first number on top of the numerator is greater than the denominator, and none of these had that relationship. But I'm still going to simplify. 22 and 10 can both be divided by 2, so I'm left with 11 over 5. Now 11 over 5 cannot be simplified any further, so I'm just going to circle that. It's not matching anything right now. Next one, 70 over 130. I love fractions that trail with zeros on both the top and bottom because essentially you can just slice through them. Slicing through them is the equivalent of dividing by 10. 70 divided by 10 is 7. 13 divided by 10, 130 divided by 10 is 13. So I wind up with 7/13. Now looking at these, there's only 2 that end up being equal. Both of these fractions or ratios simplified to 7/13. Therefore, my equivalent ratios are 70 to 130 and 14 to 26. Now, continuing on, ratio questions, true or false. So I have various food items that were randomly selected off clip art. I have 3 cheese wedges, 3 hot dogs, and 2 buckets of popcorn. And we're going to answer true or false questions based on the items I have here. So it says here, for every 1 popcorn, there must be 2 pieces of cheese. So I think it's easiest to do this with labels to compare equivalents. So it's telling me right here that my popcorn and cheese, it said for every 1 popcorn, there should be 2 pieces of cheese. That's what they're telling me. Now I need to see if this ends up being truthful. So my number of popcorn in my pictures is 2. My number of cheese in my picture is 4. So looking at this, I need to see if there's a scale factor that relates these two numbers. So 1 times 2 takes me to 2. 2 times 2 takes me to 4. That works out. I would say that is a true statement, because for every 1 popcorn, there's 2 pieces of cheese. I could have also proven this to be true by simplifying 2/4 to equal 1/2, which would match with this original ratio perfectly. Next question. If Carla has 3 dozen hot dogs, to maintain the same ratio, she needs to buy 22 popcorns. Holy moly. So first off, I'm going to write my labels out that I'm comparing hot dogs and popcorns. And according to my picture here, I have 3 hot dogs for every 2 popcorns. And looking at this, they're telling me that she needs to buy 3 dozen hot dogs and 22 popcorns. So I need to see if that's equal to a popcorn count of 22. And I'm not going to put 3 here because they said 3 dozen. And 1 dozen is equal to 12. So if I have 3 dozen, that is 36. So now what I need to do is try to find a scale factor to relate these values to prove it to be true or false. Now 3 times 12 is 36. 2 times 12 is 24, not 22. So this is going to be false. The same scale factors need to be present here. Otherwise, you'd have 2 unequivalent fractions. And in order to be able to say that they have the same ratio, you need to find the same scale factor relating those numbers. Thank you so much for following along during our ratio mini lesson. Good luck on your activity that follows. And if you need any extra help, please feel free to Zoom me or message me. Thank you.